Hello students, welcome to Sort of Source classes. In this video, I'll be solving 2015 IIT JAM stat paper for you, and you will be given more of the videos in the next session of our channel. So keep watching our channel and stay tuned for more videos. Let's start with question number 15. In question number 15, we are given that x1 to x10 be the random sample of population with probability distribution given by P theta x is equals to theta plus 1 multiplied by x to the power theta for 0 less than x less than 1 and 0 for otherwise, and this is for theta greater than 0. Now the likelihood function will be given by L of theta is equals to product of theta plus 1 xi whole to the power theta, and this is for I to n, and this gives us theta plus 1 whole to the power n product of xi to the power theta. Now let me add a page. So we can say that log of L theta is equals to n log theta plus 1 plus theta summation of log xi. This is for I is equals to 1 to n. So del log L theta by del theta is equals to n by theta plus 1 plus summation of log of xi. This equals to 0. So we can say that n by theta cap plus 1 is equals to summation of log xi. This gives us theta cap is equals to n plus summation of log xi by minus summation of log xi for I is equals to 1 to n. This is also for I is equals to 1 to n. Now we have to check if this really is the MLE of theta, as in the question we are asked to calculate the MLE of theta. So how to check this? Now we take the double derivative of log L theta. That gives us del theta 2 of log L theta is equals to minus n by theta plus 1 whole square, and this is less than 0 for each theta. So we can say that theta cap is equals to n plus summation of log xi by minus summation of log xi. So this is indeed the MLE of theta. Now let's move on to the next question, and the next question is question number 18. In question number 18, we are given that x be a simple observation from population having exponential distribution with mean 1 by lambda. So we can say x belongs to the exponential distribution with mean is equals to 1 by lambda. So we can say that f of x is equals to lambda e to the power minus lambda x for x greater than 0 and 0 otherwise. Now we are given that there are two hypotheses, h0 is to lambda is equal to 2 and h1 is to lambda is equals to 4. So we have to check h1 is to lambda is equals to 2 versus h1 is to lambda is equals to 4. We are also given the critical region. The critical region is x greater than equals to 3. So the critical region is x greater than equal to 3. Now we have to calculate the value of alpha and beta. We have to calculate the value of alpha, that is type 1 error, and beta, that is type 2 error. So first let's check what will the value of alpha. Alpha is type 1 error, so alpha is equal to probability of rejecting H naught given H naught is true. Let me add a page. That is probability of x equals to 3 for lambda is equals to 2 is equals to 1 minus f of x 3 given lambda is equals to 2. That is equals to 1 minus 1 minus e to the power minus 2 into 3. That equals to e to the power minus 6. So the value of alpha is e to the power minus 6. Now we will calculate beta. Beta is type 2 error. So beta is equals to probability of accepting beta is equals to probability of accepting H naught given H1 is true, and that equals to probability of x less than 3 given lambda is equals to 4. That is Fy is equals to 3 given lambda is equals to 4. This will be equals to 1 minus e to the power minus 4 into 3. That is 1 minus e to the power minus 12. So the value of beta is 1 minus e to the power minus 12. Well, thank you for watching the video. For more videos of IIT JAM solutions, you can keep checking our channel. Thanks for watching. Stay tuned.